Welcome to the deep dive. Today we're asking the question, can AI learn to see like a surgeon?
Oh, that's a good one.
Yeah, it sounds like something straight out of science fiction, right?
It does.
Well, researchers are actually developing systems that can generate videos of surgical procedures. We're diving into a paper all about this called VISAGE, Video Synthesis Using Action Graphs for Surgery.
That's right. VISAGE focuses on laparoscopic surgery.
Like the minimally invasive kind.
Exactly.
Where they use tiny cameras and instruments.
Yeah.
Okay, so before we even get into how it works, I'm already curious.
Yeah.
Why generate videos of surgeries in the first place? Why is this important?
Well, it opens up a whole new world of possibilities.
Okay.
You can imagine hyper-realistic surgical simulators for training, AI assistants that can guide surgeons during operations,
Oh, wow.
and even systems that can predict complications before they even happen.
Like a heads up.
Yeah, exactly. So this technology has the potential to completely revolutionize how we approach surgery.
It's like a total game changer.
Yeah.
But I have to admit, my brain is already starting to hurt thinking about how complex this must be. I mean, where do you even begin to teach an AI to understand surgery?
Yeah, that's the tricky part.
Yeah.
Surgical data is kind of like a rare gem. It's scarce, it's complex,
I can imagine.
and every surgery is unique in its own way. Traditional machine learning models, they need tons and tons of data.
Data hungry.
Yeah, exactly. So training them on surgical procedures is a real challenge.
So how did these researchers behind VISAGE tackle this data problem? What did they do?
They came up with a pretty ingenious solution. They call them action graphs.
Action graphs.
Yeah. Think of it like a visual recipe that describes everything that's happening in a surgical scene.
Okay.
It lays out all the organs involved, the instruments being used, and even how they're all interacting with each other. So basically, it gives the AI a structured blueprint to follow.
So it's like translating the complexity of surgery into a language the AI can actually understand. But how do you actually go from an action graph to a video?
The paper mentions something called diffusion models, and honestly, that sounds a bit intimidating to me.
It might sound complex, but the idea is actually quite elegant. So imagine you take a perfect photo.
Okay.
And you start gradually adding more and more noise until it becomes just a jumble of static. A diffusion model learns to reverse that process. So it basically denoises that static until you get back to that original photo.
Oh, that's interesting.
Yeah. And VISAGE takes this concept and applies it to videos.
Right.
So they start with an initial frame from a surgery and use the action graph to guide the generation of future frames.
Oh, that's really cool. So it's like the AI is learning to predict what happens next in the surgery, frame by frame,
Right.
based on what it sees in the initial frame and what's in that action graph.
Yeah.
Did they mention what types of surgeries they used to test this out? Like what kind of data were they working with?
They focused on cholecystectomies.
So gallbladder removals.
Yeah, exactly.
Yeah. They worked with a data set called Collect 50, which contains 50 videos of these surgeries. And what's really cool about this data set is that each frame is labeled with what's called action triplets.
Action triplets.
Yeah.
Okay.
So these triplets specify which instruments interacting with which organ and what action is being performed.
It's like having a super detailed play-by-play for each surgery.
Right.
I imagine having that level of detail is really important for training the AI.
Absolutely. This rich annotation really allows VISAGE to dive deep and learn the subtleties of the entire surgical process.
But even with such a specialized data set, I imagine there were still some challenges. What were some of the things they had to overcome?
Yeah, for sure. Even with this really great data set, there were some hurdles they had to jump.
Okay.
One of the things they had to do was filter out static scenes where nothing much was happening.
I guess you don't want to train an AI on a bunch of nothing.
It's like trying to teach someone to cook by just showing them a pot of water sitting there. It's not very helpful.
Yeah, not very exciting.
You want to focus on the action.
Right.
Exactly.
Were there any other data quirks that they had to account for?
Another hurdle was dealing with those abrupt cuts in the videos.
Like jump cuts.
Yeah, jump cuts where the camera suddenly jumps to a different view.
Oh, I can imagine that would throw the AI off.
Exactly. It'd be like trying to follow a recipe when someone keeps ripping pages out of the cookbook.
Okay, yeah, I get it.
To handle these jump cuts, they used a combination of techniques, including a really cool tool called PSNR detect.
PSNR detect.
Yeah, it can automatically spot those scene changes.
Oh, very handy.
Yeah, very helpful.
So they had to really carefully curate that data to make sure the AI was learning from the best possible examples.
Exactly. You want to make sure you're using good data.
Right. But let's get to the results. Did VISAGE actually work? Could it generate realistic surgical videos?
The results were really impressive.
Yeah.
They used a bunch of different metrics to evaluate the quality of the videos that VISAGE generated, comparing them to the real surgical videos.
Like judging its performance.
Exactly. And one of these metrics is called Frechet Video Distance, or FVD, where a lower score means the videos are more realistic. VISAGE scored much lower than other state-of-the-art video generation models.
So it actually worked. It can generate videos that look like real surgery.
Yeah, it's pretty amazing.
That's really impressive. But I'm curious, how did they actually incorporate those action graphs into the model?
That's a great question.
Yeah.
So they experimented with a couple different approaches. At first, they tried using a simple embedding layer.
Embedding layer?
Yeah, it's essentially assigning a unique code to each action triplet.
Okay.
But then they took things up a notch, and they used something called CLIP text embeddings.
Hold on. CLIP. Remind me what CLIP is again.
Oh, yeah. CLIP is this really fascinating model that can link images and text.
Right.
It's been trained on tons and tons of data. It can understand both visual and textual information.
So instead of using arbitrary codes, they used CLIP to connect those action triplets to a richer understanding of what they represent.
Exactly. It's like giving the AI a surgical diction.
A dictionary.
Yeah, to help it grasp the meaning behind all those actions.
So it can speak surgery.
Yeah.
Clever. Did using CLIP actually make a difference in the performance?
It absolutely did. They found that using CLIP embeddings really boosted VISAGE's performance. And then they even fine-tuned CLIP specifically for this task, making it even better at understanding the nuances of surgical language.
So they basically gave CLIP a crash course in surgery.
They did.
Did they explore any other ways to make the most of those action graphs?
Yes, they did. They also experimented with different methods for fusing the information from the action graph and that initial video frame.
Okay.
One approach was to just combine the features using a simple linear layer, but they also tried using something called a cross-attention layer. And the cross-attention layer allows the model to selectively focus on different parts of the input.
Cross-attention, that rings a bell. That's a term that's being used a lot these days, especially in those big, large language models. Is it playing a similar role here?
Exactly. It's all about directing the model's attention to the most relevant information. And it turns out using cross-attention led to a big improvement in the quality of those generated videos.
So it sounds like VISAGE is learning to pay attention to the right details in both the action graph and the initial frame, just like a human surgeon would. That's really cool. But before we go any further, I want to shift gears a little bit. I'm starting to think about the potential downsides of this technology. What are some things we should be considering as this develops?
Of course, with any powerful technology, it's really important to think about the ethical implications.
Right.
But in terms of just the model's performance, they also took a deep dive into how VISAGE compares to other cutting-edge models for video generation.
Oh, interesting. I definitely want to hear more about that. Let's get into how VISAGE stacks up against the competition.
Sounds good.
So let's talk about this AI model face-off. What other video generation models were they comparing VISAGE to?
They compared it to 4 other leading models.
Okay.
Waldo, Cody,
I've heard of that one.
Stable Video Diffusion.
That's a mouthful.
Yeah, SVD for sure.
Okay, SVD.
And then the Latent Flow Diffusion model, or LFDM.
Got it. So 4 other top contenders,
Yeah.
each using a different method for video generation. It's like a real algorithm battle royale.
It is.
But what were the judges looking for? How did they determine which model was the best at generating these surgical videos?
Well, they used a combination of quantitative metrics that are standard in the field.
Okay.
One that we've already talked about is the Frechet Video Distance, or FVD.
Right. Lower score means more realistic.
Exactly.
Okay.
But they also looked at things like peak signal-to-noise ratio, or PSNR.
PSNR, okay.
That one measures the overall image quality.
So how crisp and clear the videos are.
Exactly.
Okay.
And then they use something called Learned Perceptual Image Patch Similarity, or LPIPS.
Another mouthful, LPIPS.
Yeah, that one measures how similar the generated videos look compared to the real ones.
So how well they capture the essence of real surgery.
Exactly.
Okay.
And then finally, they looked at the Structural Similarity Index Measure, or SSIM, which focuses on how well the models preserve the structure of the original videos.
So it's like they're judging these AI surgeons on their technical skills, their artistic flair,
Yes.
and even their bedside manner.
That's exact.
Okay, so that's a lot of criteria. So tell me, how did VISAGE do in this AI surgical Olympics?
VISAGE did exceptionally well.
Really?
Yeah. While LFDM actually achieved the lowest FVD score among the models that were just used for inference without further training.
Okay, so straight out of the box, LFDM might have had a slight edge.
Yeah, you could say that.
But what about overall?
When you look at the total package, VISAGE was the clear winner. It had the best scores across almost all the metrics.
Wow. So it may not be the absolute best in every single category, but overall, Visage is the top performer.
That's pretty incredible. But I'm a visual person. Did they actually watch the videos and compare them side by side?
They did, and this is where things get really interesting.
Okay.
They found that Cody, one of the contenders, just couldn't keep up. Couldn't keep up how?
It failed to produce videos that looked convincingly real.
Ah, so it just couldn't quite capture the realism of surgery.
Right.
Interesting.
And then another model, Waldo, had trouble with artifacts.
Artifacts, like those weird glitches and distortions you sometimes see in AI-generated images?
Exactly.
So some of these models are still a bit rough around the edges.
Yeah, they're still learning.
Okay, so Cody struggled with realism, and Waldo had some visual glitches. What about the other models? LFDM, SVD, and Visage. How did they fare in this visual test?
Well, all three of them produced videos that resembled real surgical footage pretty well.
Okay.
But Visage had a distinct edge. It was able to generate those fine details with remarkable accuracy.
Like what kind of details?
Things like the very tip of the surgical instrument, things that are critical in surgery.
It's all about the details, especially when you're talking about something as precise as surgery.
Exactly.
It sounds like Visage isn't just generating videos that kind of look like surgery. It's capturing those nuances that would actually matter to a surgeon.
Exactly.
That's really impressive. Did the researchers try to figure out what it was about Visage design that made it so good at this? I'm particularly interested in those different ways they condition the model on the action graphs. Did they look into that at all?
You read my mind. They did a deep dive into those different conditioning methods, comparing two main approaches. First, they tried using a simple, learnable embedding layer for the action triplets.
So, like assigning each action triplet a special code?
Precisely. But then they took it up a notch
Right.
and used those CLIP text embeddings we talked about before.
Right. So instead of just arbitrary codes, they leveraged CLAP to connect those triplets to a deeper, more semantic understanding of what they actually represent. Did they find that using CLP improved Visage performance?
It made a huge difference. They even went a step further and fine-tuned the CLIP text encoder using the image generation objective itself.
Wait, they fine-tuned CLIP, so they essentially gave CLIP specialized training in the language of surgery.
Exactly. They fine-tuned it to make it even better at understanding those surgical terms and generating visually accurate video frames. And the results were undeniable. Using CLIP with fine-tuning led to the best overall performance.
It's like they sent CLIP to medical school.
They did.
That's amazing. It shows how important it is to give AI the right kind of knowledge. But remember, they also experimented with different ways to fuse the information from the action graph and that initial video frame. What were those techniques again?
They explored two main techniques: a simple linear layer that combines the features through concatenation.
Okay, so just merging the information together.
Yeah, but they also tried using a cross-attention layer.
Cross-attention, that word keeps popping up. It seems to be a key player in all sorts of AI tasks.
Yeah.
How does it work in this context?
Cross-attention allows the model to selectively focus on different parts of the input.
So it's like the model is learning to pay attention, just like a surgeon would focus their attention on different areas during a procedure.
Exactly.
That's fascinating. Did using cross-attention lead to better results?
It did. They found that using cross-attention led to a significant improvement in video generation performance, and it didn't matter how they encoded the action triplets.
Wow. So it seems like directing the model's attention is really crucial for creating realistic surgical videos. It's amazing how these AI techniques are mimicking the cognitive processes we see in humans. But before we get too lost in the technical details, I'm curious, did the researchers find anything surprising or unexpected during their analysis of Visage?
They did, and it really highlights the importance of data quality in AI research. Remember how we discussed the challenge of surgical data being scarce?
Yeah, finding enough good data to train these AI models is a major hurdle.
Well, it turns out, even within that CollectT50 dataset, not all the data was equally valuable for training Visage.
Oh, interesting. What kind of issues did they encounter?
Some of those video segments had very little motion.
So trying to train an AI on those segments would be like trying to teach someone to dance by showing them a still photo. You need to see the movement, the flow.
Yeah.
So what did they do about those low motion segments?
They had to develop a way to identify and discard those static scenes.
So they had to make sure Visage was learning from the most dynamic and informative parts of the video.
Exactly. It's like they hired a video editor to cut out all the boring parts and create a highlight reel of the surgery.
Smart. But were there any other data quirks they had to deal with? It's like they gave Visage its own surgical highlight reel to learn from.
Yeah, smart. But you mentioned there were other data quirks they had to handle. What else did they have to clean up?
Oh, those jump cuts were a real pain. Remember, those are the parts where the camera suddenly switches to a different view. It really interrupts the flow of the surgery.
Yeah, that would make it tough for the AI to follow along.
To deal with this, they used a bunch of different techniques, including that PSNR detect tool we talked about.
Right. That can automatically find those jump cuts.
Exactly. It's really helpful for identifying those tricky spots. But they also cleverly use those action triplets as a guide.
They made sure that all the frames within a training segment had at least one common action triplet.
So they use both the visual information from the videos and the semantic information from those action triplets to create these really clean and consistent training segments.
Exactly. It's all about giving Visage the best possible data to learn from.
Garbage in, garbage out, right?
Precisely.
It sounds like they went above and beyond to make sure Visage was learning from the best possible examples. It was like they set up a surgical boot camp for this AI. This has been an absolutely incredible deep dive. We've gone from the basics of surgical video generation to the nitty-gritty of Visage and its potential impact on the future of surgery. What's the one big takeaway you hope our listener walks away with today?
I hope they come away with a sense of awe and excitement for the future of AI in healthcare. Generating surgical videos is just the tip of the iceberg. There's so much we can do with this technology to push the boundaries of what's possible in medicine. It's a field that's absolutely exploding with potential, and I, for one, can't wait to see what the future holds.
I know. It really makes you wonder what's next. If Visage can learn to generate videos of gallbladder removals, could it be trained on other types of surgeries? Could we use it to create simulations for even more complex procedures like heart surgery or brain surgery?
Those are excellent questions, and I'm sure researchers are already exploring those very possibilities. This technology has the potential to revolutionize so many aspects of surgery, like training, planning, and even real-time assistance during an operation. It's a really exciting time to be following this field.
It truly is. Thank you so much for taking us on this incredible journey into the world of AI-powered surgery. It's been mind-blowing, to say the least. And to you, our listeners, keep those questions coming, keep exploring, and stay curious.